Hi guys, in this video, we'll walk through some of the most asked React interview questions. So, if you're someone who's just looking to learn React or have an interview coming up, this one's definitely for you. So, what is React and what are some of its key features? React is an open source JavaScript library developed by Meta for building user interfaces, especially single page applications. Now let's look at some of its key features. The first key feature is component-based architecture. The UI is built using independent, reusable pieces called components. The second key feature is virtual DOM. React uses a lightweight, in-memory representation of the real DOM. It updates only the parts that change, improving the performance. The third key feature is JSX, which stands for JavaScript XML. JSX lets you write HTML-like syntax inside JavaScript, making code more readable and intuitive. The fourth key feature is unidirectional data flow. So what this means is that the data flows in one direction, from the parent component to the child component, making app logic more predictable.
The second question is explain the virtual DOM and how React uses it. Let's first understand the problem and how virtual DOM helps. The real DOM, which is the document object model, is slow to update because changing it can cause the browser to re-render the entire page or large sections of it. Here's where the virtual DOM comes into the picture. It improves performance by reducing direct DOM manipulation and preventing unnecessary re-renders. How React essentially achieves this is using the algorithm called differential algorithm. The differential algorithm in virtual DOM is how React finds the differences between the old and new virtual DOM trees after an update. It quickly checks what changed and updates only those parts in the real DOM.
The third question is, what is JSX? JSX stands for JavaScript XML. It's a JavaScript syntax extension that allows you to write HTML-like code directly inside your JavaScript. So this piece of code has both HTML and it is assigned to a variable, so it has JavaScript as well. So this element variable represents what you want your UI to look like. The fourth question is, what are the types of components? React components are mainly of two types, functional components and class components. Functional components are simply JavaScript functions that return JSX. For example, this piece of code where you use the function keyword to define the functional component and it returns JSX. Class components, on the other hand, are the older style where you use ES6 classes and lifecycle methods. For example, this piece of code where you use the class keyword to define the class component, which also returns a JSX. Today, functional components are the standard because they are cleaner, faster, and work with hooks, which is our next topic. So let's take a look at hooks and some of the most commonly used hooks. Hooks are special functions in React that let you use features like state, side effects, and more inside functional components. So they are specific to functional components. Let's take a look at the use state hook. It is a local state hook, meaning its values are limited to the component in which it is used. This is the most common hook. It lets your component remember things like a count, a form input, or a toggle. So here we're declaring a count state variable and a set count function to update it. Initially, the count variable is initialized with the value of 0 using the useState hook. You can then use the set count to update it when, let's say, a button is clicked. Other hooks include useEffect, useContext, useMemo, and useRef. You can read more about these. Also note that you can create your own custom hooks in React. The next question is, what are props and state? Think of props as parameters you pass into components. Just like you pass arguments into a function, props let you pass data from one component to another, usually from a parent to a child. Props are read-only, which means once a component receives them, it can't change them. That makes props perfect for displaying static data or customizing a component. For example, in this piece of code, the app component is passing the name prop down to the greeting component. And the greeting component, which is the child component, then uses that name prop to display hello, Alice. But remember, props can't be changed inside the child component. They are fixed unless the parent changes them. Now let's talk about state. Unlike props, state is internal to a component. It's like the component's personal memory, data it can keep track of, and more importantly, update. State is perfect for interactive stuff, like tracking a counter, toggling a menu, or handling form inputs. So in this code here, the counter component is initializing the count state variable with an initial value of 0 via the useState hook. And what this component is essentially doing is displaying the number of times the user clicked the button. So once the user clicks on the button, the on-click event triggers the updation of the count variable using the setCount function. So once the count state variable is updated, what React essentially does is re-render the component with the updated value of the count variable. So now that the count is increased to 1, we display that you clicked one time. The seventh question is, what is conditional rendering? Think of when you want to show something only if a certain condition is true, like showing a login button if the user isn't logged in, or showing a welcome message if they are. That's conditional rendering, and it's easy. It works just like regular JavaScript logic because React JSX is basically JavaScript with HTML-like syntax. So in this app component, if the value of the isLoggedIn variable is true, we display a welcome back message. Else we display a login button. As simple as that. The eighth question is, what is prop drilling? Prop drilling happens when you pass data from a parent component through one or more intermediate components to reach a deeply nested child. The middle components don't care about the data, but they still have to receive it and pass it down. Here in this piece of code, the user has to go through app component followed by the parent component followed by the child component followed by the grandchild component, even though the user prop is used only in the grandchild component. Now, why is this a problem? As your app grows, this becomes hard to manage. A small change to a prop's name or structure can break multiple components, and your components become more tightly coupled, meaning less reusable and harder to maintain. Here are a few better options than drilling props through everything. The first option is React Context. So create a context and provide the value at a higher level rather than passing it down via multiple components. The other option is to use state management libraries like Redux, Zustand, or Recoil, which are great for complex apps. One of the most asked interview questions is, what are error boundaries? Error boundaries are components that catch JavaScript errors in the UI, so your whole app doesn't crash. Without them, if one small component throws an error, React will unmount the entire component tree below it. That means users could see a blank screen. Now, why do we need error boundaries? React is great at rendering UI, but it doesn't automatically handle runtime errors. That's where error boundaries come in. They act like a safety net. If something breaks inside the boundary, it catches the error and shows a fallback UI instead of crashing the whole app. Now, how to create an error boundary? So here's an example piece of code that defines a component named error boundary, and you can choose to display whatever you want as a fallback UI. It could be as simple as displaying something went wrong. Now, how it's essentially used is by wrapping it around a component. Now, if my component throws an error, the boundary catches it and shows a fallback message. Now let's learn about an important concept, code splitting and lazy loading, which helps in improving the performance of applications. So here's what's happening in this piece of code. The import my component tells your bundler to code split and create a separate file for my component. And react.lazy tells React to lazy load that file only when my component is rendered. The purpose of this is all about performance. It reduces your initial bundle size and speeds up the first load of your application. And this ensures users only download what they actually use. The result is faster load times and a smoother user experience, which is especially important for large applications.